Okay, welcome everyone. So I'm going to talk about the challenges and pitfalls of integrating research software, a Bio2Byte case study. So the Bio2Byte group, we are working on predicting characteristics of proteins. You have a cloud-based Django implemented website basically with online tools, and databases. Everything is working all in one structure. We have our code in a Git repository. We're working on easy installation of tools and containers, but how did we get here? Now, I wish very much that it was like this, a journey on a nice straight road, but in reality, it's been more something like this, starting at the bottom of the mountain, and definitely with the weather not as nice. So I'll tell you a bit about our journey of developing software from a more practical research point of view, so making things available in a real-life research environment, and how you can hopefully make it more like the journey on the left and not the one on the right. This is also partially a story about how technology has developed and what is possible now, but what was not possible when this journey started, because a lot has changed in the last 7 years. So first of all, it started with Dynamine. So Dynamine is a predictor of protein backbone dynamics, that we implemented together with Elisa excellently in Java and the Weka framework. She also makes a very nice website, Elisa WordPress, with a Python backend. We put all this in a SVN version control system and life is good. But then we realized, okay, we need to run this actually on proteome scale or on many sequences. So Java and Weka does not work. It's a memory hog, super slow. We make a Python version, but then also create a different repository. And now what about the website? We need to update it because Python is much faster. We already have Python anyway. So this needs to all be changed. And the original link that we gave with the article is now pointing to the Java version and not the more recent Python one, which is actually, much more valid and faster. So the lessons that we learned from this, I think, are try to plan ahead. Think about where your software might end up, even if you are not realizing it at the moment. Definitely keep track of software versions and use a version control system and link to that from your article. It's changeable, so you can still update it. And you can also still provide legacy versions. I think this is now pretty much standard, but in those days, it was definitely not so obvious. We then realized with Dynamine that there was a certain bias that we had in the predictions. So we fixed those and then also realized that we could do other predictions based on the same principle for sidechain dynamics, secondary structure propensity. So we had to adapt the Python code to make sure it could deal with all these different kinds of prediction and the option to turn it on and off. So this is all chugging along nicely, working with Elisa, everything's in SVN, oh, great, we're doing analysis on this, we're developing new things, and then Elisa leaves. So now I'm responsible for the website, which is on a server I do not control, and it's very hard to fix when it breaks down because it's a complex backend setup, which is basically, custom written. So lessons learned here is make your code as modular as possible and make minimal assumptions because it will save on maintenance later on. But this is not always easy in a research environment, of course. There's a caveat there. Also, version control, track everyone's code and definitely document specific implementations like the Dynamine web version and do this really, really well. Also, how you use it, how you can fix things, this is essential and will save a lot of time. So in the meantime, I was also doing some work with students from Peter Tompa's lab, and we created a resource for protein early folding data, eFoldMine. And because of Mishi, we decided to use Django and put everything on a paid server, Django Europe. This works very well, very stable, so this was all good. This is easy peasy. Dynamine, on the other hand, keeps on hiccuping. We get sometimes it overloads, sometimes the machine breaks down. And I don't know, they don't tell me about it. And of course, the local server with the SVN version on it has to be taken out of commission. So, and this at a time when actually through collaboration, the Rinspector tool is using a service to pull these predictions. So this is not good. I get lots of emails like it's down, it's not working, I have to fix it. Not a good situation. So what are the lessons learned? Do not run production code on local hardware, I would say, unless you have ample local support and also full control. And even then, maybe it's best to avoid because these days it's really not expensive anymore. Do use an integrated framework like Django for services. It's more initial overhead, but it's definitely a lot easier to maintain in the long run. Also, 2 PhD students at the time, Daniele and Gabriele, they're very productive. They create predictors for disulfide bonding patterns. We all start using Gits, yeah, so we move from SVN. We use remote servers as well to track, yeah, for the Git repository. The code's always there. We develop a new prediction tool called eFaultMine that depends also on Dynamine predictions, and in itself has an sklearn Python library dependency. So we provide this as a standalone via Git. That's the link we also give in the article. That's all easy to do, but it's not necessarily easy to install for the individual users. So the lessons we learn here are that a version control system connected to a dependable remote external server is way better. But do keep your dependencies at least to a minimum if you can, and track which versions of the dependencies that you use. Yeah, because it's the more dependencies, the more difficult it's going to be to install locally. We also realize at this point that we really need a website to show what we've done so far. So, of course, we go for Django, and now we choose the DigitalOcean cloud platform using a virtual machine. We develop another software called Dynamine that takes the Dynamine and eFaultMine prediction, but also is neural network based, so it has a PyTorch dependency, and also uses external software called Cypred. So, put this in Git, yeah. But this is a real nightmare to get to work, because here there's dependencies on versions of PyTorch and everything. So we're like, okay, we really need to make a website for this. We again choose Django, but we do this in a different Django version because we need to do this quickly, and it's with some people that my PhD students know. So we've set up a new Django version basically on the DigitalOcean virtual machine. So definitely try and avoid multiple possibly divergent copies of the same software. So the Dynamine version has a different version basically of Dynamine in there, which is not good. Try to have one master version which can be asked to deliver different version results so that you don't end up like having multiple Git repositories and different versions of software. And also definitely go for the cloud and virtual machines if you can, because this was much easier to work with for us than a dedicated Django server, for example, or a local machine. So in the meantime, yeah, there's other things happening as well. We developed a Mutaframe Diogen 2 framework with Marian Roman at ULB, which for various reasons at least uses a completely different architecture on a separate DigitalOcean server. On the original one, we now also install something else called ShiftScript, which is now to encoder with auto-encoded decoder system in PyTorch for NMR chemical shift data. Different Django version, because again we quickly hack one based on the Dynamine one. We also make something else called PSP, or a predictor of phase separation, and again hack in a different Django version. So web servers and services are definitely great, but do limit your architectures and approaches. Yeah, so it's not good to have different ways of doing things, because it's just going to cost a lot of time and maintenance. So even if it's not ideal or as fast, future maintenance will become a problem. And try also to integrate everything immediately, even if it takes more time and the article is delayed, because otherwise you're going to end up spending a lot of time having to fix it later, which is what we had to do, because at this point, yeah, we have the websites, we've got Dynamine, the eFaultMine and Dynamine also in there. We've got ShiftScript, we have PSP, we also have something I didn't even talk about, a legacy server that we implemented called AC Pipe from my time before I was at the VUB. And then we also, in the meantime, moved over to start to fold Django onto DigitalOcean, yeah, because what was the point of paying for a separate server? And we still, of course, also have Diogen running on a different DigitalOcean server. Dynamine, on the other hand, still keeps on crashing happily on this local server, and I often don't know about it. And we still have other software that you haven't even integrated yet. All of this is in different Git repositories as well, yeah, and often multiple versions, all in Python 2.7, yeah. So this is a complete mess. We then also start to get involved more with Elixir and Elixir Belgium, and they have quite high standards for what it is that you have to provide, and realize, okay, we can't work like this anymore. We really need to move to a next level of professionalism. So listen to the professionals from the start. The talks that we are hearing today, it's very important to try and use integrated frameworks to think ahead and to use it, but also choose what it is that you are going to use. You can't do everything at the same time, of course. Okay, so we've been trying to straighten the roads, move everything to Python 3.8. We have one Git repository for the tools where we have everything in there all connected and integrated. We have a Git repository for the web stuff, where we have everything in one single Django implementation connected, one DigitalOcean server. We have the master version of the Git web repository that we use for the production, on the DigitalOcean server. We also have another DigitalOcean virtual machine that we use for the development branch of Git, so we can test things and make sure it works before we actually switch it to the production version. We still have some software we haven't implemented yet. Some of this probably will never be integrated, but that's the current situation. So it's great to have everything together. This makes life a lot easier. Also, maintenance is a lot easier. Keeps the overall setup and maintenance simple. So even if the initial investment to learn these complex frameworks, often complex, it's not that easy to use Django, is higher, it does save you a lot of time in the end, and it's definitely worth the initial investment, I would say. So where to next? Now we're working on website integration. So basically one landing page where you can upload data in different file formats. You get the predictions that are relevant for that. You can visualize them. There's APIs that you can connect to. We still need to integrate a couple of tools. So this is now much easier to do because we all use the same framework. We also instituted hackathons in the lab so that people are aware of what's going on, also understand what other people are doing. On the software side, communication is key here. So we do this every 3-4 months, and this really helps also with people engaging with the software and the code. We keep involved with Elixir, so now we're also making containers, for example, trying to make things available like via Galaxy, also because that gives much higher exposure to the software. So try and link to existing frameworks, which is also good for advertising your software. So just to summarize then, it is a research environment that we work in, so you can't really expect things to be as straightforward as in a company. The destination is fuzzy. We don't always know where we are going to end up. And iterations of your code will always be required. It's a learning process. As you get better at it, you can probably save yourself some more time. Like, I knew about a lot of the things that I did wrong in advance, but in a real life research environment, we have many other responsibilities and we have to get that next paper out, and that's always more important. You can, however, think ahead and organize meetings, improve the coding background so that people are at least constantly aware of what's going on. One problem here is that many in bioinformatics come from a computer science background and have formal training in this. So, this also needs a bit of time and effort from everyone, but often some people are better at it. They can help each other out. Hackathons are a great idea for that. It's also worth the effort to learn to use integrated frameworks. This initially takes a lot more time, but it will save you a lot of time on maintenance. So it's more of a long-term strategy. And also, what is the use of developing something that no one can use afterwards? If you hack your own custom scripts, nobody can use it, then what's the point of developing it? Just make sure that you use something that is actually then also usable by other people afterwards and make it available. And also definitely use the cloud for anything in production, and for code that needs to persist, don't use your own local frameworks. So this is obviously not all done by me. There's a lot of people that I've worked with in the past on this. At the moment, Luciano Kagami is really doing a lot of work on the website, so I want to thank him in particular. And then, of course, everyone from the group. And we are thinking actually of further professionalizing this, the pipelines, and we are looking for someone. So if you think you're interested in this, please do get in touch. And then I think it's question time.
Thank you very much, Wim. Great talk. Thank you. That's a lot of excellent advice. For our audience who are unfamiliar, I wonder if you would mind describing what Galaxy and Elixir are.
Yes. Well, Galaxy, I think we've heard this morning. So, but yeah, Galaxy is basically a platform where you can that integrates all kinds of different softwares from people that are bioinformatics related, so that they can all be run from a single place, right? Elixir is the big European infrastructure project for bioinformatics. So basically, what they're trying to do is create an infrastructure basically that's interconnected, that enables people to find bioinformatics tools that are connected to each other, so that it will be much easier, for example, if you have a protein, to find all available prediction and information about that particular protein, which at the moment is not trivial because a lot of the tools are separate. So they're trying to bring together the approved tools, the better, more referenced, whatever tools, to make those available to everyone in the community. Yeah.
Okay, thank you. And harking back to something else we heard about this morning is running hackathons for your lab. Seems like a fantastic idea. How do you organize those? Do you arrange them around a specific topic? How popular are they?
I think they've proven to be quite popular because there is, so to take a step back, basically what I wanted to try to say with this talk is that many of you are, very involved in making sure that you develop nice code. You're probably also making something that is new, which is also different. It's always easier to make something than to maintain it, and to then suddenly integrate other stuff that came from the side, but somehow needs to be integrated in the whole framework as well. Yeah. So what I'm trying to show is that over the last 7 years, we've developed many different things, but they all need to be integrated. Yeah. The people that have been doing this are typically PhD students, so they come and they go. By the time they leave, they're often very good at this kind of thing, or much better, at least, than when they came in. But people also come from many different backgrounds. You have people that come really from a biology angle, people that come more from chemistry, all kinds of different directions. So they don't necessarily have any background in programming, or like very little, sort of a hacky type of background. So what is important about these hackathons is that people can learn from each other, and they can also understand where the problems are, because I think this is also something that for many of you is very obvious. Like, how does Git work? Like, why are we using Git in the first place? I mean, to us, this is obvious, yeah? But for someone who's not on programming, this is not necessarily obvious, because they're like, okay, well, I have to learn this thing if I can when it works, for example. Yeah? So these are just issues that come up. So the hackathons are very good to try and get everyone to talk to each other about this, and to just focus for 1 or 2 days every so many months on the coding itself. Really the technical side of things, which is, again, in the typical research environment, not what you spend the most time on, unless you get the scope to do so within the research project that you're working on. But this is quite unusual, I would say, in general. Usually it's more about, we do method development as well, so usually it's more about that than about making sure that everything is like, following the latest technical developments and making sure everything is really nice. And there's a balance there, a pragmatic balance between how nice the code is and how well we're up to speed with developments, and just making sure it works and that we can publish it in the end.
There's another question in chat, but I'm curious to follow up on that a little bit. So the hackathons are involving some technical coaching for people who are maybe newer to programming?
It's more like, okay,
pair programming or something?
We basically start with, because at the moment we're still very much in a transition phase, which is probably gonna be never ending. In my experience, these things are never fixed and finalized. Now it's more about, okay, what do we still have, and what are the current biggest issues that need to be solved, and then we just distribute some people to work on that, and then we meet again a couple of hours later to discuss what's been happening and see how far we get and what we could possibly do. So it's more of an organic process, really. And then often problems are identified that I hadn't even noticed yet. But the key thing there again is learning, right? I mean, you can learn programming in a very structured way when you follow courses. That's one thing, but then there's also, again, the real life environment. So it's more about organically showing people what's happening. And then they also realize, okay, now I have to learn this. It's so in that way, it can be very motivating as well, I think. Because if you don't realize why it's necessary, then you won't be so motivated to learn. If you realize, oh, this is really, I can see now that can become a real problem, then it's going to be much easier for you to pick it up because you want to learn it, because you know it's going to be relevant later.
I don't remember from your talk if you mentioned you're using GitHub and Bitbucket. Are you using the issue tracking systems in those as well, or how are you keeping track of things you need to work on?
Yeah, so we're using now Bitbucket fully because it's just, we started with that and most of our stuff is in there. We have tried to use the issue tracker there, started a couple of times, but it hasn't really picked up, I must say. Yeah, ideally we would. But I think this is going to be a next phase once we have everything a bit better organized, and maybe we will actually try and use that. There was also some issues, I think at the last hackathon we looked into this. There were some issues with making that available and accessible via the whole Atlassian framework, which wasn't so obvious. It was a bit better on the GitHub side, but then we're in Bitbucket now, so so it was a bit of a struggle. But we're looking into that, definitely.
The question from chat was from Alex. Are your hackathons organized at IB2 in Brussels or broader, or is it just within?
No, so these are just within the group. Yeah, but I think hackathons are very useful if there are some. I mean, I know. So Alex here, for example, also organizes hackathons, but they tend to be a week, which is quite a commitment. You really have to be into that particular field to be able to commit to that, I think. But probably like IB Square, IB Square is the Inter-University Institute of Bioinformatics in Brussels. Hackathons at that level would probably be also very interesting because often people are working on different things, and there might be connections between those methods that you could implement to get new data out, for example. I mean, integration is always an issue in bioinformatics. There's so much going on at so many different levels that integration can really give a lot of new insights as well.
I asked you in the, it looks like we've got a couple of extra questions. Do you do code reviews? They're a nice way to exchange info.
At the moment, no. But so I guess we use the hackathons in a way to review the code. But like now, our key issue is to integrate the legacy code that we have. It has not been integrated yet, to make sure we get that to work in one integrated framework. And but there's a lot of cleaning up still to do. When I look at it, I sometimes think, oh no, but anyway, it's working. It can be much better, so I think that's going to be the next phase.
I asked a question about Git and Subversion in the chat, and I just wanted to extend that a little bit. I wonder if there's anything you miss from Subversion after moving from Git.
Well, I started off with CVS, right? It was the concurrent version system, whatever. Then SVM, that was very limited. SVM was a lot better, and it was actually working fine. I think the limitation there is that you have to go to one remote server, as far as I understood it at the time anyway, which is a limitation, but also makes it much easier to use because there's like one place where everything lives. Whereas with Git, it took me a while to get my head around it as well, because it basically everything can live anywhere, right? And then also with the branching system and the patches. So because of its flexibility, it's also not easy to use. Again, if you've been using it for a while, this sounds rather reasonably trivial, but it's not so trivial to understand how it works, I think, if you don't come from, again, if you don't have that background, because it's just very complex. The fact that you can have multiple copies everywhere, and it's there's no real So, but I like it now. But it took me a while to get used to it. SVN is definitely much simpler in terms of
conceptual model, maybe.
Yeah.
To change subject completely, you said something earlier in your talk about starting off with Java, and then you moved to Python from Java because of speed. That's something fairly surprising. I wonder what the story is behind that.
I personally, I have done some coding in Java a long time ago. I've never really used it that much. We were using the Weka machine learning framework in Java for this linear regression algorithm, which basically what Dynamite is. And it took enormous amounts of memory and was very slow. We even looked into like speeding it up in Java. Somehow that didn't work very well. And then I wrote a custom Python implementation that was like, I don't know, orders of magnitude quicker, basically, with minimal memory usage. So that was then an obvious one to change to.
Indeed. Broadly speaking, maybe a surprising result, but a great result in that case.
Yeah, but actually Python does surprisingly well with speed-wise with many different things. Also with like, I also worked in the past with projects where we had enormous memory usage with lots of objects that were interconnected and everything, a data model in essence, and it held up really well, even at that level. So yeah, I'm a big fan anyway.
Yeah, fantastic, great. Great.
Except for the move from 2 to 3, that's always
that was
actually, it wasn't that painful in the end, but yeah.
You came in at the right time, probably. Yeah. Earlier versions of Python 3 didn't have the nice features to allow you to move things. Okay, well, I think that's it. Thank you very much for joining us. Thank you.